to all. I, Mr. Shashank, welcome all the participants for the awareness webinar on supply chain logistics, which is organized by SANATHANA Research and Training Institute, a unit of SANATHANA Samprathishtana, Mysuru, in association with Rotary Club of Mysore-West. Prayer is the process of talking to God in order to achieve a purpose. So let us begin this webinar by seeking the blessing of Lord Almighty. Vakratunda Mahakaya, Koti Surya Samaprabha, Nirvignam Kurume Deva, Sarva Karyeshu Sarvada. Now I request Dr. Ramachandra C G, the Managing Trustee of SANATHANA Research and Training Institute, to welcome and introduce the speaker of today's webinar. I also request him to welcome the guests and the participants.
A very good morning, one and all. So I take this opportunity on behalf of SANATHANA Research and Training Institute, which is an unit of SANATHANA Samprathishtana, Mysuru, to welcome today's speaker, Dr. P. Sivasankaran, Associate Professor, Manakula, Vinayagar, Institute of Technology, Pondicherry, and officials from Rotary Club of Mysore-West and participants from different parts of the country. So let me introduce today's speaker. So Dr. P. Sivasankaran has obtained BE degree in Mechanical Engineering from Pallavan College of Engineering, Kanchipuram, and ME in Industrial Engineering from Tyagaraja College of Engineering, Madurai. He has obtained his PhD in Industrial Engineering from Anna University in the year 2015. He is having total 10 plus years of teaching experience in various cadres and currently is working as Associate Professor at Manakula Vinayagar Institute of Technology, Pondicherry. He has published a total 35 papers in reputed international and national journals and also presented many papers in international conferences. He has published books on quality management, process planning and cost estimation, managerial economics, and computer integrated manufacturing. Automation for Excellence. He has organized 15 workshops and guest lecturers on recent technological advances in the area of industrial engineering. He is a peer reviewer and editorial board member of various reputed international journals. He is a life member of Indian Institute of Industrial Engineering, Mumbai, and IING USA and Teaching and Education Research Association, Eurasia Research. He is proficient in software such as design for assembly, AutoCAD, Robotic A, etc. And he has guided various academic projects for UG, PG students. He is regularly applying for projects, seminar grant, FDPs, STTPs under various schemes such as DST, CSIR, NS and TM, even as well as ASCTE. He has carried out a novelty research in the work titled Comparison of Jute and Sisal Fiber Reinforcement Composites using Crust PCB with the support of C Intel Services, Chennai. He has actively participated in various FDPs, national and international workshops, STTPs at various institutes. He has delivered guest lectures at the institution level and also at reputed industries on the topics related to software applications and other industrial engineering areas. The beautiful thing about the learning is that nobody can take it away from you. So that's why never stop learning. So when we stop learning, then we stop growing. So learning gives creativity. Creativity leads to thinking, and thinking provides knowledge. So knowledge makes us great. So knowledge is divine. So knowledge is powerful and it should be shared. So today's topic is supply chain. Supply chain is a network of business and activities that takes a product from raw materials, suppliers to end customers. But by defining, logistics refers to the process of acquiring, transporting, and storing resources along the supply chain and logistics. The basic difference between logistics and supply chain management is that logistics management is the process of integration and maintenance, including your flow and storage, etc., of goods in an organization, whereas Supply chain management is the coordination and management of supply chains of an organization. So the main role of logistics in supply chain management is primarily to increase the overall value of each delivery, which is identified by customer satisfaction. This means that the reduction and optimization of labor resources must be tied in with keeping up a certain level of quality customer service. And even the 7 R's of logistics, according to the Chartered Institute of Logistics and Transport UK, defines them: getting the right product in the right quantity, in the right condition, at the right place, at right time, to the right customer, and at the right price. So today's national webinar, supply chain logistics, the speaker will going to give the overview of this, what exactly the supply chain the logistics. Within the case study, he will going to explain and enlighten us. With this, I wish all the participants will have a fruitful interaction with the speaker. Once again, I thank one and all. Over to you, Shashank.
Thank you, sir. Now I request Dr. P. Sivasankaran, Associate Professor, Manakula Vinayagar Institute of Technology, Pondicherry, to start the session.
Very good morning to one and all present here. First of all, let me introduce about myself. I am Dr. P. Sivasankaran, currently serving as Associate Professor in the Department of Mechanical Engineering, Manakula Vinayagar Institute of Technology, Pondicherry. So our today's webinar topic is focused on logistics network management. So the current title of the workshop, Optimization of Logistics Problem in Transporting the Materials Using Linear Programming Model. Okay, so we are going to discuss quantitative analysis, mathematical programming model. Okay, with the help of that, so we are going to discuss a practical problem, vehicle routing problem for a logistics flow management system in a dairy industry, right? Let us have the today's agenda. First, let us go with the preface of the logistics, the problem, followed by objectives of the logistics network problem and conceptual framework, then a brief literature review collection, then conclusion of the literature gap. So what is missing in the past and how that can be tackled with the help of the quantitative tool to find out the solution. The next, a case study about the dairy industry logistics network, then mathematical model. So solving the case study with the help of the so-called linear programming model, mathematical model using OR approach. Then discussing the results obtained through mathematical solution, then the final conclusion and references. So in this way, we are going to proceed with the discussion as per the sequential pattern. Let us start with the background of the supply chain logistics. So the basic, the overview about what is supply chain logistics. So these are the two operations, supply chain management and logistics management, are the two most important activities that are performed in an organization. In today's the current view, most of the organizations are planning to strengthen their logistics or transportation network with the help of 3PL, the third party logistics, in order to group the activities more faster, okay, by considering timely delivery of product to the market. Okay, because a manufacturer cannot do all the activities as a single handed. So he has to depend on the third party logistics in order to group all his products, okay, with an intermediator. He might be a wholesaler or a distributor. Okay, so they will work for the manufacturer in order to channelize the products quickly within a short span of time to the customer market segment without having any delay, time delay in, okay, by considering the customer service request. So supply chain is the process of managing the flow of activities from the point of origin, that is from the material stage. Okay, so the supply chain process deals with material ordering and procurement of raw material from the supplier to manufacturer. Okay, whereas the logistics, it is a mechanism that tells about how you are going to transfer the end items like food products, medicines, automobile. So these are the final, the product which are in finished state. Okay, so through which mode of logistics you are going to transship all those end items exactly to the customer location. So the logistics are related to the operation or a process that involve the distribution of finished goods from the company's warehouse to the market. So this is the small discrimination between what is supply chain process and the logistics. So there is a distinction between these two terms, supply chain and logistics. So the raw materials are ordered as per the demand and the supply constraint. So which one? The supply chain management that deals with the supply and demand constraint. Okay, it relates to order progress and fulfillment process. The logistics related to planning and distribution of goods from the source to destination, from warehouse to market destination. So in practice, in real time, there are many tools, quantitative tools are applicable to solve such problems or issues, challenges related to logistics and supply chain network decisions. So these are the classification of tools that are given here as per the existing literature survey. So we can classify into two models, quantitative models and qualitative models. If you say quantitative model, so many papers, the authors have described the output, the problem solution with the help of the numerical computation approach, optimization model like mathematical programming, and near approximate solution using algorithms. And some authors, they compared both the performance of algorithm with the mathematical model, right? So in this way, they have done the work, the quantitative modeling analysis for the so-called the problem selection, logistics network problem. And qualitative survey, that is qualitative model. Some people have gone for surveying techniques. So finding which is the best possible the vehicle routing problem for a given source and destination. Okay, so through survey network, survey methods, collecting field data, okay, then statistical application using regression forecasting models, right? So these are the other area which covers the logistics network management problem through qualitative network, through qualitative model. So these are the various clusters that are available in the field of optimization for solving the logistics problem. Now coming directly to the objective of the problem or the proposal. So in this research environment, in the research problem, the main common challenges faced in the dairy industry are addressed here with the help of the linear programming modeling technique. So in the given problem, the objective is to minimize the travel distance of logistics by finding the shortest path in order to deliver the dairy products to the market with respect to the constraints like time, distance, and supply. So this is the so-called objective model which has been taken for formulating the linear programming equation, objective function. Objective is to minimize the cost of transporting the items from one end to other end based on the consideration of the distance travel, the cost of distance travel. The constraints are supply, distance, time. This is the general objective function. When we are going to see the case study, I have changed certain parameters. Okay, so I have to constrain as supply demand, objective function as a transportation cost in my problem. But generally, people will try to work out with the constraint as time, distance, and supply. Okay, so reducing the distance, we can able to reduce the transportation cost of shipping items from origin to the final destination. The objective can be solved by using Lendo solver package. That is the software which I used in the case study, the discussion, using Lendo solver package, the linear optimization problem. So we can able to measure the given objective by meeting the supply and demand situation in the dairy industry. So this is the basic framework of my problem. Okay, there is one main hub, the main hub. There is one main hub. From here, the finished items are delivered to the warehouse. So from the warehouse, okay, the products will be sent with the help of the intermediate distributor, and these are the various the service points, the demand centers, the destination points. Now the distributor has to decide the fleet size and the holding cost of inventory and also the transportation cost with reference to the distance from this point to the next point. So these are the challenges he has to consider while transshipping the items from one location to another location. So now before going into the main the case study, let us see what is meant by vehicle routing problem in logistics management. So vehicle routing problem commonly focus on finding out the most optimal routes for a particular group of vehicle based on the given constraint, operational constraint like time, length of the route. Then the fleet managers, that helps the fleet managers to plan the route in order to maximize the efficiency, that is maximizing the transportation cost, okay, by minimizing the delivery time of the product. So this is the so-called the objective taken for the vehicle routing problem in most of the research article paper. Now let us discuss what are the classifications of vehicle routing problem. So these are the three basic types that are available. Vehicle routing problem with multiple trips. So this scenario which explains the n number of vehicles can travel in more than one route for a given source and destination. Second one is open vehicle routing problem. Here the vehicles will not have a fixed destination and the source. So it will be keep on continually transferring the items from one end to another end. So I can explain cross-docking example in the next slide for the second one. A multi-depot vehicle routing problem. It will have multiple storage points. So that will occur in existence, for which the vehicle has to begin its own starting and end point. Now for the second one, I told you what is open vehicle routing problem. So here in this network, in the graphical network, in between pickup node point and delivery point, there is a centralized storage area that is called cross-docking area. So the vehicle from the pickup node point will come and store the items here. And similarly, the delivery vehicles will try to collect these items from the storage area that will drop to the final end destination. Okay, so here there is no standard the waiting point, that is source and destination. So each and every vehicle will be moving around the clock, right? So after servicing, it won't move to the depot. So these are the various classifications of problem till up to the last slide. Now coming to the research literature, the literature review. So in the present section, the research analysis is carried out with the 10 couple of papers, the past research articles focused on the dairy logistics problem. So based on the study, the past study, the tool usage for the problem can be analyzed, okay, with the help of the linear programming model. So how the LP model is selected. So I'm going to present all the 10 papers, so out of which the research gap for identifying the optimization strategy with the help of the linear programming model, that will be presented in the conclusion session of the literature review after going through all the 10 research articles. The following are the brief survey that are collected based on the past research work done by many scholars. So here, a structured survey on the supply chain practices in dairy industries are taken into consideration. So the first article here in this paper, the authors have considered the papers published in the most peer-reviewed the journals, and they categorized the data according to the recent 11-year studies. So based on the collection of data, they divided the subject into three main components, such as distribution management, risk management, and decision-making strategies in logistics system. Based on the findings of the study, the result shows that the quality of the food safety, okay, the quality of making and economics of dairy industries are mainly focused on the technological innovation, okay, then removing barriers, uncertainties in the demand by smoothing the logistics flow. In the second article in this paper, the authors have addressed the quality benchmarking by conducting a survey in order to understand the barriers of dairy industry by using a tool called interpretive structural modeling. So using this approach, the author addressed the point of traceability of items, then unbalanced production line, and also over processing time of the finished product. These are some of the key obstacles that are taken. In addition to that, they also used another tool called Micmac analysis to find out the barriers. So both the tools strongly support the decision maker to improve the efficiency of the dairy industries. Then the third paper, so here the authors have discussed the common challenges faced in the supply chain of transportation network system. So they took dairy industry situated in Madurai. They conducted a case study. So according to the problem objective, the vehicle will collect milk from various collection points and finally it will drop the products to the end location. Authors found that optimized route used in the dairy industry by considering the distance, cost, quantity, and number of vehicles used, and also the road conditions. So these are the parameters they considered in formulating the linear programming model approach for minimizing the transportation cost. In the next article, author aims to collect the problem which are commonly faced in the raw milk collection point and transportation system. The proposed research, the factory will send the truck to collect the raw milk from the various farms. The objective is to minimize the total transportation cost and the maintenance cost as well as the cleaning cost of the truck. In this research, the authors used modified differential evolution algorithm. It is an extension of GA, genetic algorithm, to solve the proposed problem. The next article, which tells about the finding out suitable distribution strategy and optimal route planning by considering the cost, minimization of cost and time during the transfer of goods from source to destination. It is a multi-objective problem. In addition to that, the customer demand and also allocation of items may vary from location to location based on the size of orders. So they used modified genetic algorithm, which is named as distribution strategy selection and vehicle routing algorithm. The proposed algorithm tries to outperform by comparing the mathematical model. Okay, so these are the three notes they have taken for problem solving. One is direct shipment, milk run, and number of the cross docking points efficiently. Then the next article in this research paper, so they introduce two types of pricing strategy, namely dynamic pricing and disruptive pricing, which is applied to manage the demand along with the various location, inventory cost, and routing decision. So in this work, they followed an integrated location inventory routing model, which is considered to solve all various supply chain logistics disruption in routes, pricing sensitive method, and the product shelf life. So the proposed model constructed by using a mixed integer nonlinear programming model, since here the demand is fluctuating, so they took nonlinear integer programming model in order to find out what is the total profit of the supply chain network system. So the next paper, which tells about the aim of dairy industry to improve the performance of transportation cost by reducing the focus of supplier milk run route. So this work tries to find out the most appropriate model, optimization model, to solve the cost objective function model in terms of total distance. The optimization model used here is integer linear programming formulated by traveling salesman problem. Then the next paper, which describes a model for solving multi-objective vehicle routing problem with the soft time window constraint that specifies the earliest date, earliest time and latest arrival time of the customer. If the service time of the customer before the arrival time, then they have to take additional extra inventory. If the customer service time is carried out after the arrival time, then penalty cost is also taken into account. So both transportation cost and the required fleet size is minimized in this model. So therefore, the total transportation cost consists of direct cost, extra inventory, and penalty cost. The proposed multi-objective problem is solved by using GA algorithm. Then the next article, which tells about a cooperative multi-depot vehicle routing problem. So in this research, authors have established a mathematical model for multi-owner vehicle routing problem, in which each owner manages a single or multi-destination point. So the authors have presented the idea with the help of a game theory techniques for cost solving allocations. So the next paper, which tells about the process and functions of cold chain logistics food delivery system. So here the objective is to find out the minimum delivery cost of items for a fleet of identical vehicles that departing from a depot, visiting all the customers only once and returning to the depot. That is the constraint taken here. Also, authors proposed genetic algorithm along with the mathematical model, and comparing to model, their proposed genetic algorithm gives the efficient solution. So with this literature survey from the past, the literature survey, different authors have adapted various surveying methods, both qualitative and quantitative methods, in finding out the solution for the logistics network problem. So in my problem, I just tried with the LP modeling, assuming that supply demand are equal to linearity concept, but in reality, that is not possible. Okay, so just I treated it as a linear programming model. So based on which I constructed a problem framework for dairy industry network by considering source, the main hub as Pondicherry, and the demand point as Coimbatore, different various the service centers, right? So the vehicle has to start from the main hub, from the source point, and it has to deliver the products from various end locations. Okay, so this is the general framework as taken. Then coming to the case study, the mathematical model using linear programming approach. So in this case study, so consider a milk shed area located on the 3 routes within the Pondicherry location, namely Vallalar Salai, Vinayagar, and Sitananda Nagar. So these are the source points situated in the Pondicherry region. And there are 6 receiving centers in Coimbatore, namely Edayarpalayam, Kurinji Nagar, Saravanampatti, Prakasam, Papanayakampalayam, and Raja Street Colony. So each route is able to supply on an average 1000 liters of milk per day. The supply of milk on routes from Pondicherry, namely Vallalar Salai Road, Vinayagar and Sitananda Nagar, are 150, 160 and 190, the 1000 liters respectively. The daily capacity in 1000 liters of receiving centers in Coimbatore, so namely in Edayarpalayam 140, Kurinji Nagar 120 numbers, then Saravanampatti 90, Prakasam 150, Papanayakampalayam 100, and Raja Street Colony 250 respectively. The cost of transporting 1000 liters of milk from each route to each receiving center that differs according to the distance data. The cost in rupees, the transportation cost in rupees are shown in the following table. So the table 1, which describes the transportation cost from source to destination. So these are the supply demand data, which is given at the top. Okay, and this one, which represents the transportation cost from source to destination, from independent source to destination. And X11, X12 are the decision variable, unknown decision variable. Okay, before going to solve a mathematical model, so we have to give an objective function by adding an unknown decision variable, because we don't know which route is the minimal shortest path that will try to reduce the cost of transshipping the items between the source to destination. So we have to select the best point, a nodal point for fixing the source and destination to plan all our the delivery of the finished items between 2 points. The next one, distance data between source to destination. Okay, so the problem is to find out what is the minimum total cost of transportation. Okay, so methodology used here, the above application problem can be formulated by using LP model, linear programming model. The illustration shows the objective function and constraint as described below. So now we are moving over to the solution part of the case study. So here, objective is minimization. So use the minimization objective function followed by the transportation cost. Okay, this is the general schematic representation of the cost objective function, followed by various decision variables that are multiplied along with the cost function, subjected to the constraints, supply and demand constraints. This is the general notations. Now the working model has been briefly described here. So minimum the transportation cost, that is the objective taken here. So referring to table 1 data, so construct the objective function by taking all source and the demand data, destination point, referring to table 1. So whatever the transportation cost which is given here, so in this order, formulate the objective function like this, and subjected to the supply constraint. Okay, that is summation of x11 plus x12 plus x13 plus x14, that is equal to 150. That is the capacity, the supply capacity, okay, between source and destination. Likewise, demand constraints are written here. Okay, now this problem can be solved using lingo model. Okay, so while solving in the software, we have to write like this. Okay, the earlier slide, that is a free handwritten the expression for the given objective function and the corresponding the constraint, the set of equations. While writing in the software, so we have to model like this. Then the answer, the solution obtained through with the help of the Lindo solver has been represented here. The final objective function, the minimum transportation cost, the model output is given here, and also number of iterations, the proposed model solved for several trials, and total decision variables taken, and the number of constraints that are taken. These are the data which are written as a model output. So from this, the results and discussions are given here. The above model is solved by using Lingo Solver package by considering the objective function as minimization of time with respect to the following constraints as supply and demand. So the model has a 12 decision variable varying from x11 to x34 respectively. The number of iterations solved is 5 and total number of constraints is said to be 8. Therefore, the cost function is measured to be rupees 5,240 rupees. So this is the minimum total transportation cost which is required to transfer the item between the source and destination. From the above analysis, the best routes are also taken based on the cost of transporting the milk from the source to destination, referring to the table 1 data. So these are the 6 best routes. So Vallalar Solid to Gandhipuram, that is from Pondicherry to Coimbatore. Then Vallalar Solid to Edayarpalayam, then Villiyanur to Saravanampatti, then Villiyanur to Gandhipuram, then Sithananda Nagar to Kurinji Nagar, then Sithananda Nagar to Saravanampatti. These are the 6 best routes that are selected depending on the overall objective function data, referring to table 1. So the final conclusion of today's webinar. So before going to the conclusion, let us recap all the main points, whatever we have come across. So first we started with introducing the pre-framework of the logistics management problem. What is what? Then vehicle routing problem, different types of vehicle routing problem. Then the problem objective of logistics management challenges, then followed by the case study and all numerical the data that are introduced in the case study as a benchmark exercise. Then software tools, methodologies used in the case study are addressed till up to the previous discussion. Now with all this basic input, I conclude that the logistics network operation involves more number of complex, the challenging decisions, starting from transferring the goods from starting point to the final destination point. So in this practical situation, in this work, the practical situation is studied and analyzed the performance of the logistics network problem, especially vehicle routing problem. So the quantitative model approach is used to solve the logistics challenges from source to destination. The objective taken is minimizing the cost of transporting the milk product from source to destination with respect to the distance covered. Thus, an attempt has been made to solve using Lindo Solver package, an open source software tool, okay, that is considered for formulating the objective and the so-called the constraints. And these are the references that are collected here. So I thank the participants for their patience listening. And also I thank the program, the coordinator, for allowing me to share my basic experience on the logistic situation, the various complexities that are faced in the day-to-day activities. Okay, so as a nutshell, I have just given a small case study. If anyone interested to do a research in this area, so you can do a lot of the basic literary works before going to touch a quantitative model analysis. So with this, I end my the presentation.
Thank you, sir. Now I request, thank you, sir, for the wonderful and informative session. Now I request the participant can ask the question and interact with the speaker by unmuting themselves. The provision is given to you.
So anyone is having any clarifications or you want to ask the speaker directly, you can ask, unmute yourself and ask speaker, he will answer to you. So if there is no questions, we'll move forward. Shashank.
Yes, sir. I request Dr. Ramachandra C G, the Managing Trustee of SANATHANA SAMPRATHISHTANA, to summarize today's webinar.
So first of all, let me thank today's speaker, Dr. P. Sivasankaran, so for giving the complete details about this supply chain logistics. And since so many the different the FDPs he has with us from last year. Once again, I thank him for giving the complete details about this topic. And coming to the today's topic, which he has taken supply chain logistics, and that he has clearly mentioned what is the difference between the supply chain, what is the importance of supply chain management, as well as the logistic management, how these two were clubbed together, okay, to get the advantage in the area of this logistics. And also he has mentioned these two, the topics, the supply chain as well as logistics management are the two emerging areas. So everywhere it is being used. And he has also mentioned the few quantitative models which are used for this purpose. For example, mathematical models as well as algorithms can be used, as well as the qualitative models also he has discussed with us. It might be a surveying methods or field data collection and even statistical application also. And he has taken one particular case study to make us understand about this, what exactly the supply chain logistics, how it can be used for the one dairy industry has taken example. And a lot of literature also he has shared with us. So what all the work which is already being carried out in this particular area. And also he has discussed with us with his case study the linear programming model in detail, and even the Lindo solver, the software model also he has discussed how best by using either the qualitative or the quantitative the model. So we can implement this, both the supply chain management as well as logistics in the delivery of the product. So as rightly said by him, the manufacturer, whatever he manufacture, so he cannot deliver the product to the end user or the customer. So for that reason, that purpose, we require this supply chain management and logistics. Worldwide, it is having its own importance. So all of us, either one or the other way, we might have ordered the either the your Zomato food delivery or even Amazon and Flipkart, any item you might have ordered. The complete tracking, including when your order is confirmed and which particular the nearest area, so he has confirmed, and whether packing is done, whether it is out of delivery, when it will reach us, the complete the details you can check, and including some of the cities express delivery also same day, within this hours also you can able to get. Suppose you have in the Amazon Prime membership you have, so without any additional charge, the same day, if you are in a particular city, or at least in one day, the express delivery, it will be delivered to you. So many examples we can take for the supply chain and logistics and all. The Zomato, that is the, especially in the COVID lockdown period. So most of them earlier, only few people were using it. So a lot of people they started using how exactly, okay, it will go to them, the nearest person who is involved in that the chain, and how it will be gets delivered within the stipulated the time. So that's what there is a huge requirement, large opportunity is there in this area, supply chain and the logistic management. And if anybody, as rightly said by the speaker, anybody is interested to do any research and all, so definitely there is a scope for this. So even I thank all the participants also for joining with us to know about this the topic. Once again, I thank everyone. Over to you, Shashank.
Thank you, sir. Gratitude is the essence of humanity. I thank Dr. P. Sivasankaran, Associate Professor, Manakula Vinayagar Institute of Technology, Pondicherry, for accepting our request to be the resource person of today's webinar and also for delivering a very informative session. Thank you, sir. I thank Dr. Ramachandra C G, the Managing Trustee, SANATHANA Research and Training Institute, a unit of SANATHANA Samprathishtana, Mysuru, and officials from Rotary Club of Mysore-West for the involvement in organizing this webinar. I also thank Sri Lokesh C G, President, Dr. Raghavendra Prasad, MD, Dr. Shantaraj Aras, and Srimati Bhagya Gopal, Board of Trustees, SANATHANA Samprathishthana, for their support extended in organizing this webinar. Finally, I thank all the participants for their support and active participation in this webinar. Thank you, one and all.